All right, let's go ahead and get started. Today we're going to be doing lecture 3, evaluating expressions. So I wanted to start off with the substitution principle because this is very important in math. If you have two things that are equal, like A and B, let's say if A equals B, then that means that A is the same thing as B and B is the same thing as A. So if A equals B, we can replace A with B and vice versa. So we can replace A with B, and if we have B, we can replace that with A. So what does that look like in practice? Let's say we have a really quick example. Like let's say we have A equals 3, right? A equals 3. Well, we know that A and 3 are going to be the same thing. So wherever I see an A, I can replace it with a 3. So let's say A equals 3, and we want to evaluate A squared. So what I'm going to do is I'm going to replace A with a 3 everywhere I see the A. So that's going to be A squared is equal to 3 squared, and then 3 squared is equal to 3 times 3, right? Which is 9. So our answer would be 9 there. So what we're doing is we're taking an algebraic expression like A squared, and we're replacing the A with a number. Because really, if you have a letter like A, we're talking about A as a variable. But if A is a number, we can replace A with that number in any expression. So that's what we're going to be doing today. We're going to be evaluating expressions. And I'm going to be taking this from the notes and the problem sets, and I'm going to work a couple of those out, and then I'll leave you guys alone to work on the classwork. So let's go ahead and look at the problem sets, and I'll do a couple of those. All right. What we're going to be doing is we're going to be doing 1 through 8. Okay, now for all of these, we're going to be using the same numbers. So the directions are we want to evaluate each expression using the values below. I want to evaluate each expression using the values below. Okay. So what are those values going to be? Those are going to be in no particular order. A is equal to 4. B is equal to 8. C is equal to 2. D is equal to 7. E is equal to 3. F is equal to 9. And G is equal to 10. So we're going to be using all of these. For every single problem that we do. Okay, let's take a look at number 1. All right, the first one we're going to do is we're going to do A times B plus C. So here we're given the expression AB plus C. And we know what A is. We know that A is 4. We know what B is because B is equal to 8. And we know what C is because C is equal to 2. So what I'm going to do is I'm going to replace A with a 4. And then we're multiplying, so I got to put a dot between. I know that B is 8. So I'm going to replace B with an 8. And then I'm going to add C, which is 2. And then I'm going to work out what this is. So I know that 4 times 8 is 32. I'm doing multiplication first because we have to keep in mind the order of operations, right? PEMDAS. So we do our multiplication first and we do our addition last because 32 plus 2 is going to give you 34. That'll be our answer. So all we're doing is we're replacing letters with numbers, and then we're seeing what that's going to evaluate to. Let's try number 2. 2 is going to be 5 times a plus b squared. 5 times a plus b squared. Now you know it's going to be multiplication if the two numbers are right beside each other, but there's no multiplication sign in between. You're just going to assume that that's going to be 5 times a. So the first thing I do is I replace all my letters with numbers. I know that I can replace a with 4, so I get 5 times 4. I know that a is 4 because of this, right? Plus, I bring down my plus sign, and I know that b is going to be 8. B is going to be 8, so this is going to be 8 squared. And now I do the order of operations. So I've got 5 times 4, that's multiplication, but I've got 8 squared, which is an exponent. So I'm going to do the exponents first. I know that 8 squared is 8 times 8. That's going to give me 64. I have this plus sign in the middle, so I'm going to bring that down. And I still have 5 times 4. 5 times 4. So now we've got multiplication to do. 5 times 4 gives me 20. I bring down my plus 64. And then the last thing I do is I add. 20 plus 64 is going to give me 84. So that's going to be my final answer. All right. So that is evaluating expressions. That's all there is to it, pretty much. Let's take a look at number 3. 3 is going to be 7d minus 2g. 7d minus 2g. So what I'm going to do first is I'm going to replace the d with a 7, since I know that d is equal to 7. And I'm going to replace the g with a 10, because g is equal to 10. And now I'm going to evaluate using order of operations. So please excuse my dear Aunt Sally is going to come back. Okay, so I have no parentheses, I have no exponents, I don't have to worry about that. I do have to multiply 7 times 7 to get 49. And I do have to multiply 2 times 10 to get to 20. And then the last thing I do is I subtract. 49 minus 20 is going to give me 29. And that's my answer. Let's try number 4. 4 is going to be BC minus C cubed minus C cubed. So here's my expression. I know that C is cubed because there's a 3 as an exponent. So I know I'm going to have to cube something at some point. The first thing I do is I replace my letters with numbers. So I know that B is 8. B is going to be 8. And I know that C is going to be 2. So I'm going to replace the C with a 2. So now I've got 8 times 2 minus 2 to the 3rd power, or 2 cubed, as we said. Let's do the exponents first. 2 cubed is going to give me 8. I know that because 2 times 2 times 2 is going to give me 8. That's the same thing as 2 cubed, right? So I know what 2 cubed is. It's going to be 8. And then I bring down my 8 times 2, since I'm just doing one step at a time. So now I've got 8 times 2 minus 8. I do multiplication next. 8 times 2 is going to give me 16. Bring down the negative 8, or the minus 8, whichever way you want to think about it. And 16 minus 8 is indeed going to give me 8. So I'm done. And you keep on going until you reach a single number, and then you're done. Okay. Let's try 5 and 6 on the next slide. Five and 6. 5 is going to be dA squared. 6 is going to be G times B plus E. Okay, so we know that D is equal to 7. I replace D with a 7 times A squared. A is going to be 4, so I'm going to replace A with a 4. Now you can evaluate this. I know that 4 squared is going to be 4 times 4. That's 16. And I get 16 times 7. 16 times 7. If you don't remember how to do this, you could do it vertically. 16 times 7. The first thing I do is I do 6 times 7. That's going to give me 42. I put down the 2 and I carry the 4. Now I do 7 times 1. 7 times 1, which is 7. But if I add this 4 at the top, I get 11. So once I put down my 11, I get 112. And that'll be my answer. 112. All right, let's try 6. 6 says G times B plus E. The first thing I do is I replace my letters with numbers. I know that G is 10. I know that B is 8. And I know that E is 3. Okay? So all I've done so far is I've replaced my letters with numbers. And the reason why I do that is because of the substitution principle, right? We talked about that on the first slide. So I know that G and 10 are the same thing. I know that B and 8 are the same thing. And I also know that E and 3 are the same thing. So I can replace E with 3 and B with 8 and G with 10. Okay? So now I evaluate it based on order of operations, right? I do the parentheses first, then I move on to the exponents, then I move on to multiplying and dividing, and adding and subtracting. So let's do the parentheses first. Inside the parentheses, I see 8 plus 3. That's going to give me 11. But that's still in parentheses, right? And the 10 is still on the outside. So I bring down the 10. And now I have multiplication because you see 10 times 11, 11 is in those parentheses. That means we're going to be multiplying these two numbers together. And I get 110. That's my answer. Okay. So once you get to a singular number like 110 or 112, you're done. But all these steps in between have to be shown for you to get full credit. Okay, so make sure you show your work. We're going to be moving on to 7 and 8 on the next slide. So I'll leave this up there for a little bit. So the first thing I always do is I replace my letters with numbers by the substitution principle. You know, whatever numbers they give me at the start, that's what I stay with. Once I've replaced my letters with numbers, I use order of operations to figure out how the expression turns into a mess like 10 times 8 plus 3, and then ends up as a singular number like 110. But that's basically the way it goes. All right, let's try 7 and 8. These will be the last two that we do together. Okay, 7 is going to be A plus B. In parentheses, by B, we have F plus G. F plus G. And then 8 is going to be A plus B all over 3. So the first thing I'm going to do is, by substitution principle, I'm going to let A be 4. I'm going to let A be 4 because they tell me A is 4. I'm going to let B be 8. I'm going to let F be 9 and G be 10. So now I'm ready to use order of operations. The parentheses comes first. So I'm going to do whatever is inside parentheses first. 9 plus 10, that's going to give me 19. And I'm going to keep that in parentheses, by the way, while I bring down the 4 and the 8. Now I'm ready to do addition and multiplication. The multiplication is going to come before addition. So 8 times 19, that's going to be, let's see, 8 times 9 is 72. Carry the 7. 8 times 1 is 8. 8 plus 7 is 15. So that'll be 152. And then I bring down the 4. So now I've got a 152 plus 4, and that's going to give me 156. Done. So that's number 7. Number 8, I have A plus B on top. I'm going to replace A with a 4, and I'm going to replace B with an 8. All the while keeping the 3 at the bottom. So what happens here? Well, since we're dividing by 3, we kind of want to do that first. But if you remember parentheses are always going to look like this. Now, the top of the fraction is going to be considered a grouping symbol. So we're actually going to do the top of the fraction first, and that'll simplify a little bit, as you'll see later. So let's do 4 plus 8. We know that that's going to be 12. 12 is still divided by 3. And then 12 divided by 3 is going to give me 4. So what we did there is we started at the top, and then we moved on to divide by what's on the bottom, or what's called the denominator. So we start here, and then we divide later, because the top of the fraction and the bottom of the fraction are called the numerator and the denominator, and those are kind of separated out by grouping symbols, even though you don't see them. So you could consider the top as being inside a grouping symbol and the bottom as being inside of a grouping symbol. So that's the way I like to think about it. And it's a whole lot cleaner when you do it that way.